Also very warm welcome from my side. Nice to have you here in this tech talk on optimization of product configurations. And yeah, I want to start with introducing our sample company today. It's Happy Trucks, and yeah, we will configure the product of Happy Trucks in our configurator today and try to optimize it. Yeah, the main product of Happy Trucks is a forklift truck. So a forklift truck has a cabin, it has an engine, different engine types. We have wheels here and forks and a mast. And yeah, this is Nico, and Nico wants to configure a forklift truck today within our configurator. And Nico has some requirements. So yeah, he wants to have a diesel engine in his forklift truck, and he wants to use this vehicle outdoor. So Nico, very good. Let's see if we could find an optimized solution for you in our configurator. So this is now a Happy Trucks configurator. This is a mock-up or a prototype just created for this day to show how easy optimizations could be implemented on top of our VT technology. So Nico wants a diesel engine. So let's give him this diesel engine as an engine type. And you could see there's a delivery time is now being calculated, and it is 23 days. And next, Nico wants to get some outdoor tires. And, okay, so he could click on outdoor, and again we see delivery time is being calculated, and it's now 20 days. Okay, so every time Nico selects a value, the delivery time is being calculated again. Nico has now the question, are there other options that could improve my delivery time? And yeah, he could try it. So he could go back to the configurator and just click around and say, okay, what if I click on rotatable yes? Then again, delivery time is being calculated, 22 days. No, this was not the best solution. So again, 20 days. Okay, so this could be annoying. And yeah, Nico has the feeling that he do not get the optimal delivery time with this approach. So how should he find the best forklift truck with the optimal delivery time for his needs? Okay, Nico, no worries. Here comes virtual tabulation. So with virtual tabulation, we could take the product data of the forklift truck, we could take the delivery data, and we put these data together in our ACE, configured ACE, our software. We put rules on top of the characteristic of these data. We put relations on it and restrictions, and then we compile all this data together into a valid solution space. So virtual tabulation is calculating all valid solutions of your configuration knowledge. And then for this all valid solutions or valid configurations, we could calculate the delivery time for each of these configurations, as you could see here. So delivery time for this combination, engine diesel, tire outdoor, speedometer could be a mechanical one, and the number of wheels is 3. Then we have 20 days of delivery time. For another configuration, we have 40 days or 50 days. Okay, very good. So this could now be shown to the customer or to the end user. So we see now a table view, a list view of all valid solutions in the configurator. This is now another tab here. And we see here's a filter. It's a filter on diesel, on the engine type, and on the tire type. And all the other, now we see all valid solutions with a given filter. And we also see the delivery score of each of these configurations. And Nico sees, okay, 20 is the best possible solution for my selections. Perfect. He could say apply, and then he go back to the configurator. He could do some things more, and then he could say, okay, I want to order this. He gets an overview on the configuration, and then he could say perfect or cool. Very good. But when we come to ordering, we should think about prices. And Nico also wants to know, is this the best price I could get? So I know I now I got the best delivery time, but is it also the best price? So let's go back to the configurator, and we see here we have a second panel now enabled, and this is the price panel. So we see 20,000 is the current price, and Nico wants to know, are there other prices possible? So he clicks on, he wants to change the number of wheels to 4, and as he clicked on it, we see the price is now being calculated and the delivery time as well. So 23 days, this is worse than before, and the price is also worse, 6,000 more, not good. So Nico thinks this approach is not very promising. So every time I need to change something, and it could be that I find not the best solution with this approach. So for him, it is impossible to find a configuration with optimal price and delivery time. But he has an idea. He could ask virtual tabulation to help him. So let's see again if virtual tabulation could help. So we could take, as we know, delivery data and product data, but we could also take the pricing data, put it in our packages, and compile all the data and calculate the solution space and the number of valid combinations, and calculate for each of these configurations not only the delivery time, but also the price. So now we see that for this configuration, we have 20 days of delivery time and 20,000 euro as a price. This could also be shown to the customer again. So we are now again in the list view of all valid solutions. We have a filter on it, and we see that we have all the different scores and all the different prices here in one table. And we could see, okay, this is the best delivery time, but it is not the best price. So we see there are two better prices, 18,000 and 12,000. So, okay, Nico also recognized this and sees, oh, okay, one solution has the best delivery time, okay, but there are better prices. What to do now? Yeah, Nico, this is the Pareto frontier, and I think I should explain it a little bit. So we see here on the x-axis, we have the delivery time, and on the y-axis, we have the prices. And for example, this dot has 20 days of delivery time and 20K price. Then we have other solutions, and every green dot is a valid solution. And we have 3 valid solutions that are also optimal solutions. So you will not find any other solution that has a lower price with at the same time the lowest delivery time possible. And also this one, it has the lowest price, but at the other hand, it has a very high delivery time. But all the other solutions are non-optimal. So they have both, not the best delivery time and not the best price. So this line is called the Pareto frontier. And Nico should select one of these 3 solutions if he wants to get an optimal solution. But how to select the right one of these solutions? And then we have to ask Nico, what are his priorities? And he says, okay, I want, for me, a delivery time is 3 times more important than the price. And now we show how to optimize with multi-objectives, or how to calculate a multi-dimensional score for configuration. First, we have to normalize the delivery times. So all the delivery times we have saved, we could normalize them. Then we want to normalize the prices, called NP. And then we calculate the weighted sums on these calculated values, the prices and the delivery times. And the weights coming from Nico's selection or prioritization. And with this priority metric, we could now see that the score is the lowest for, and lowest good, the lowest for this solution. So this is the best solution for the priorities Nico gave us. So we could apply and say, cool, very good. But Nico heard about sustainability, and it could be important for the future that we have a sustainable forklift truck. So he's also interested in the sustainability of this forklift truck or his configuration. So back to the configurator, we now see a fourth panel. It's a sustainability score panel. And we see there's a current value, it's 67. So if we change any value, then again, the sustainability score will change, and also the delivery time and the price will change. And this is why we need virtual tabulation again, to calculate all the different scores for all the different configurations, and then optimize on the whole space of valid solutions. So we take sustainability data, pricing data, product data, delivery data, compile it into a valid solution space, and calculate for every valid solution all the scores we need. Then we could show the priority metric to the customer, and we could, if we want to, we could click. If we want to, we could click on the list of sustainability scores to show now the list of all valid solutions. And we see now all the 3 scores and the sum of the scores, or the overall score. And the overall score we see with this priority metric is again 12 for this version, and it is still the best. But what if we change our priorities? So for example, we want to have a higher priority on the sustainability. So let's click here. And we see something has changed. So the values, the overall sums has changed, but it is still the best option for the given priority is still this one: diesel, mechanical speedometer, outdoor tires, and number of wheels 3, and a lot of other characteristics that are not important for this message. Okay, but we still see that there are other values that are better than in this configuration. So we have a better sustainability score here in this configuration, and it has also a better price. So why couldn't we take this one? Yeah, because we have prioritized the delivery time much higher than both of the other values. So Nico's changing his priority on sustainability and says, okay, it's most important thing for me now is sustainability. And then we see something has changed in our priority list, on our list. And the overall score now is 32 for this solution, and for diesel mechanical, it is now 36. Okay, so we should, if we really want this priority metric, we should take the first one. And this is what Nico wants to do now. And he clicks on apply, and we see now the sustainability score has changed, and the price has also changed, and the delivery time has also changed. And now we could do, if we want to, we could configure furthermore if we want to. And another cool thing with this priority metric is if we, for example, click on any family that has a lot of features, then these features could be shown in any order. But with our priority metric, we could provide an order that supports this priority metric. So for example, if I click here on the tire type, then we see that outdoor plus and indoor has now changed their positions, because outdoor plus supports more this priority metric than indoor. And therefore, we help the customer or the user, the end user, by showing him a priority order of any feature. Very good. So this is all that I want to show in the configurator. So if we want to, we could click on the order button, and we say, okay, request a quotation for this optimized configuration, optimized forklift truck with a given priority metric. And we have multi-optimized or optimized the multi-objective configuration by delivery time, by sustainability, and by price. Very cool. So request this quotation, and Nico says, awesome. Very good. Very cool. This is how optimization could look like in a prototype like I've shown. And now maybe since it is a tech talk, it is also interesting how this works in the backend. So now let's go to the technical background. How do we get all the data into the VT solution space? So we have several master data systems. We have an ERP system, we have supply chain management systems, we have PLMs, and we have also a lot of Excel tables in the world. And yeah, all of these tools could provide data, delivery data, product data, sustainability data, and pricing data. And with our model API, with our package API, we could provide this data to our Configit ACE. And then we could use these modules, Solution Space API, the pricing engine, the ACE integrated BOM solver, and our configuration API to provide the score calculations, all the scores, and all the priority matrices to the configurators, to all the configurator applications. So let's take a look how to get to the sustainability scores. Imagine we have a supply chain, and within the supply chain tool, we have sustainability data. And the sustainability data is constructed or calculated of a lot of different categories. So it could be interesting for a supplier if he invested in healthcare for his employees, or if he has any eco labels, or if he supports fair trading or fair producing. It's also interesting if his products or its products are the amount of reusage. It could also be interesting for the sustainability score. And there are a lot of sustainability scoring companies or agencies who are calculating these scores as a service and provide these to the supply chain management tools. So for our example supply chain, for the forklift truck, we could get a lot of scores out of the sustainability score tool. So for example, supplier C has now a score of 63, which is okay. 43 is not good, and 84 seems to be far good. Then we have other suppliers, and we have at the end, we have our forklift truck. It is also possible at the other hand, we have our bill of material, and it is now possible to set the nodes or the scores of our suppliers to map them to the certain materials, since we know to which material we have to map which supplier. And another cool thing is that we could also define a sustainability score or some sustainability values to our product lines or to our families and features. So for example, if we work with universities in one product line, we support master thesis, we support our healthcare management system to one product team in, I don't know, Bulgaria, then this could all raise the sustainability score of a product line. And this could also be added or in some way summed up with the sustainability score of our supply chain to an overall sustainability score of a product line. Cool. So we have now on our bill of material, we have sustainability scores. And with our solution space API, we now could extract all the valid solutions again in a table. And for every valid solution, we now could calculate within the bill of materials with the mapped sustainability data on every supplier. We could use our BOM solver for this solution, and we could calculate then a sustainability score for this exact bill of material, 100% BOM. So we use the BOM solver to calculate the 100% BOM out of 150% BOM, and then we calculate all the scores for all the materials and all the suppliers that are persisted in the BOM tool or BOM master data system. This could be repeated for the next configuration. As we see, we now again use the BOM solver, the ACE module BOM solver, and to calculate all these values. And this could be repeated for every configuration. How could we calculate the delivery times for every valid variant? So again, we use the VT technology to calculate the whole solution space. Then at the other hand, we have the bill of materials. We have the delivery data on every material. So this is now the delivery time. And we know with this data, we know that material B1, for example, needs 10 days for delivery and material C 21 days. And with the BOM solver, we now could go through the bill of material and add up or sum up all the delivery times or find the maximum of the delivery time to find the maximum for a given configuration. Now we will see how to provide the pricing scores. Again, we take the solution space, we calculate for every material in the bill of material, we calculate the prices, and then we sum up all the prices to get a configuration price and persist it for every variant. Now we see we also could use the pricing engine of Configit ACE to do so, and it is also possible to support here feature-based pricing and not only the material-based pricing as we see here. So we saw that we could calculate all the different scores and all the needed scores that we need for the optimization within Configit ACE and its modules. We need some data from outside systems, for example, Excel or PLM or ERP systems. It could also be maintained in ACE itself, but it is usual to use other systems to maintain these kind of data. For example, delivery data or sustainability data and pricing data as well. And then with our modules and the configuration API, we could provide a lot of different configuration applications with the same behavior. So what are the advantages to use Configit ACE and virtual tabulation to optimize configurations? So it is possible for users to find the best prices, the best delivery times, and the sustainable configurations in all valid solutions. It could be that the user has to define a trade-off, priority metric, and then we could find multi-objective optimums. We could calculate all scores that are needed within Configit ACE with the BOM solver, with the pricing engine, with the solution space API. So we don't need any other modules for that. And yeah, from a user perspective, it is also very beneficial to have this sorted list view where we have shown all the valid solutions with a score and with this green background to say this is the best solution for your priority metric. So he does not need to find or click through all the combo boxes to find the best solution and yeah, just tipping here and there, he just can use the list view. We also could use, or we could provide features and feature priorities and defaults that a user, if he uses the configurator itself and not the list view, gets help with priorities, and he sees, okay, if I choose the first one, then I could be sure that this helps me to find the better solution or get nearer to the best solution I've defined. Yeah, and I think another very cool thing, not only for the users, but also for the product management, is that you could easily analyze your whole product portfolio and find out where are optimization potentials. For example, if you see, we don't have a electronic engine type, engine type for our forklift truck with a sustainability score higher than 70. Then it might be beneficial or good for you to invest in a marketing campaign or talk to your engineers to support higher sustainability scores on, for example, this sub-product line. So I think there are a lot of advantages, and we saw a nice prototype of a configurator, how to use these capabilities of Configit ACE in optimization and virtual tabulation and the solution space. And I hope you have some questions on it. And so I say thanks a lot. And yeah, looking forward for the questions.
Thank you so much, Stephan, for your interesting presentation insights. Indeed, I have a few questions here coming during your presentation. As the time is already quite advanced, so we will definitely come back to the questions that we don't have time to answer during this session. So let's have a look at a couple of them. So I have a question coming in here that refers to what you presented earlier in the where you showed the configurator demonstration. It says, is it a good idea to normalize the scores before weight them and sum them up? But how do you handle things where high values are good, like margin or discount?
Yeah, so there are some values or some categories that have when the value is high, then it is better than if the value is low. And it is not that difficult to calculate this in our scoring. We just have to, after the normalization step, we have a value between 0 and 1. And for the values that have where the higher value is better, we just have to take 1 minus the value to get the other way around, and then we could compare it to all the other calculated scores. So this is how we do it. So it's a easy mathematical thing.
All right.
And I think we saw it with the sustainability score. So the sustainability score has the higher value is better. So 80 is better than 20, and delivery time is the other way around. So I did it with the sustainability score, where I take 1 minus the value itself.
Yeah, that makes sense. It probably helps. Thanks. So another question here is it also possible to integrate ERP and PLM systems to request prices, delivery times, and so on, and BOM resolving for every valid solution instead of the ACE modules you mentioned?
Mm-hmm. Yes, of course. So it is we need to calculate all the scores for every valid solution, and we could use the ACE modules for it, but it is also possible, for example, to use a SAP ERP system to request the delivery time in real time. So there are web services to request the delivery time or the price, and we could request them as well. Sure. Same for BOM solving in the PLM system. Yeah.
I think that's all we have time for today, unfortunately.